Welcome to an A-level revision session live on YouTube. Today we're looking at integration, so let's begin. My name is Mohammed Ali. I'm the teacher. Let's begin with our first topic, integration. Just take a moment to read through the question. In this question, you're given dy by dx is equal to 3 over the square root of x minus x. You're told that the curve passes through the point 4, 0, and the question is to find the equation of the curve. So let me just remind you of the basic principle here, which is that differentiation and integration, they're opposites. Let's make a bit of room on the side. So if you have an equation of a curve or of a line or of anything, then when you differentiate that equation, you get a formula for the gradient of the curve, and that's normally symbolized by dy by dx is equal to, and then whatever the answer is for when you differentiate the equation. So here in this example, we've got the second bit. We differentiated the equation and we've got the answer 3 over root x minus x. So we've got this bit down here. But in order to go back to the equation, we have to do the opposite of differentiating, and that's integration. That's integrating. So if differentiation takes you from the equation to the differentiated form, we need to integrate to get back. If we integrate, we'll get back to the equation. That's the basic principle. So have that in mind. And now let's take a look at what we've got. Before we can integrate, we really need to simplify this. At the moment, it's just looking a little bit too complicated to even begin integrating. So the main thing we can do is we can take the root x and rewrite that as x to the power half. So let's rub out the square root sign. And let's change that to x to the power half. And now that's starting to look a little bit simpler, but not really simple enough. X to the power half as a denominator, we can bring that to the top if we change the sign from positive to negative. So x to the power half can be brought to the top of the fraction as long as we remember to change from x to the power half to x to the power minus half. If it was negative, we change it to positive. That means we can get rid of the fraction line. And that's now looking a lot simpler than what we had to begin with. We've also got minus x, and just remember that that is minus x to the power 1. And now to get the equation of the curve, we integrate. So let's integrate term by term. Let's go to 3x to the power minus half. Let's add 1 to the power. So we've got x to the power half. We had 3 as the coefficient. Let's divide that by the new power. So 3 divided by a half, that makes 6. And on to the next term, we've got x to the power 1. Let's raise that to the power 2. We're adding 1 to the power. And the coefficient here, we can't see it, but it's 1. And we're going to divide that by the new power, which is 2. So that makes the new coefficient a half. And then there was something else in the equation that dropped out, and that's called a constant. So even though we can't see it in the answer for dy by dx, we know that in the equation there might have been a constant term, like a number like 5 or 7, and when you differentiate that becomes nothing. So we have to just put that in when we're trying to get the equation. So the equation would start with y equals 6x to the power half minus a half x squared plus some constant number that we don't know. How do we find out that constant number? Well, we know the curve passes through the point 4, 0. 4 is your x coordinate, 0 is your y coordinate. So if we put 4 and 0 into the equation, making sure we put them in the right places, we should be able to get an equation that leaves us with c to solve. So let's just do that separately. Remember, the numbers are 4 and 0, but you have to put them in the right places. So the 4 is your x coordinate, 0 is your y coordinate. So let's take the y and let's put in 0. And the x is 4. So 4 to the power half, that's just going to become 2. 2 times 6 makes 12. You can do the next bit while you're waiting for me to write 12. We've got 4 squared makes 16. Half of that is 8. And then we've got a constant that we don't know. So 12, take away 8, plus some other number has to make 0. Well, that's got to be minus 4. So 12 take away 8 makes 4. 4 add minus 4 would make the 0. So we can solve that and say that the constant has to be equal to minus 4 in order to make that top line become 0. We can use that and put that in here. Constant is minus 4. And the plus and the minus, we don't need both. We can just have the minus there. So the final answer is y equals 6x to the power half minus a half x squared minus 4. Feel free to watch that again when the video becomes available. But since this is a revision session, we're going to be moving on to the next question very, very quickly to try and get as many covered as possible. Okay, please have a read of the next question we're about to do. Okay, let's begin. We have to integrate 3 over root x minus x with respect to x. Key thing here is we need to integrate. This sign here is the integral sign, and it's got dx to tell us that the x is the variable, and we need to integrate with respect to x. Let's make ourselves a bit of room. Okay, we're going to start like before. We're going to try to make this a lot simpler. The root x, we can, if you remember, can be changed to x to the power half. You can also bring it to the top of the fraction. At the moment, it's at the bottom of the fraction. So from the bottom, we can take it to the top, and that's going to be x to the power minus a half. The half, or whatever power is there, changes sign. And now it's at the top of a fraction. But since there's nothing underneath, we can get rid of the fraction line. And we can just drop that in here. So now we're integrating 3x to the power minus a half minus the x. We're going to take each term one by one and integrate 3x to the power minus a half. The x, we're going to add 1 to the power, so it's going to go from minus a half to a half. So we have x to the power half. The 3 is the coefficient, was the coefficient. We're going to take that 3, divide it by the new power, 3 divided by a half. That makes 6 as our new coefficient. On to the next bit. We've got x, which is really x to the power 1. That's going to become x to the power 2. We add 1 to the power. And then the coefficient is an invisible 1, which we divide by the new power of 2. 1 divided by 2 is a half. And then we have to remember that when we integrate, we don't see anything at the end because it would have dropped out from the equation. So we just have to remember that there's a constant at the end. Okay, and that's all the question asked for, was to integrate, and we've done that. Okay, please take a look for yourself. Next question, we're going to differentiate. This question is about differentiation, and I've picked a harder one. Okay. Looks very complicated, so we're going to try as much as possible to make it look simpler before we start the differentiation. Square root of x, we can rewrite that as x to the power half. And now we've got x to the power half on its own as the denominator of a fraction, where we've got two things being added at the top. So what we can do is we can split this fraction into two fractions. Split the one fraction into two fractions. So the plus will be in the middle, and the 5x will be on one side, and the 3x squared on a second fraction. Let's try to do that. Just going to make ourselves a bit of space. And we're going to have, instead of one fraction line, we're going to have two fraction lines, one for each fraction. And then on the bottom of each fraction is going to be the x to the power half. One, we don't need to change that. It just stays the same. X to the power half is what was on the bottom of the fraction before, and it stays at the bottom of the new fractions. Okay, now if we can, instead of having x appear on both the top and the bottom, just appear once, it'd be easier for us. So we've got x, and that's really to the power 1, divided by x to the power half. Well, that just makes x to the power half, So I can, instead of writing x twice, I can cancel off one of them with the other, and I change to the net power, which is a half. So 1 take away the half. When you're dividing, you take away the powers, so 1 take away a half makes a half. We don't need the fraction line anymore. And we'll do the same thing to the second fraction. We've got a power 2 and we've got a power half. We're dividing, so we're going to take away the powers. So 2 take away a half makes 3 over 2. So I can cancel one of the x's with the other and change the power to 3 over 2. Don't need the fraction line anymore since there's nothing underneath. And that's looking a lot simpler now. So now the question says differentiate, and I'm in a much better position to differentiate now. I've got the equation looking a lot simpler. So let's begin. In differentiation, we times the power by the coefficient at the front. So 5 times a half makes 2.5. So I'll just write that as 5 over 2. The power on the x will be 1 less than what it used to be. So a half drops by 1, and that makes minus a half as the new power. And at the beginning, y changes to dy by dx to show that I'm differentiating. Okay, on to the next term, we've got plus. Okay, we times the power by the coefficient, so 3 times the 3 over 2, that makes 9 over 2, 4.5. I'll just write that as 9 over 2. X to the power 3 over 2, that power has to drop by 1. So 3 over 2 is 1.5. That's just going to drop to a half only. The 1.5 becomes 1 less, so that's a half. And you can stop there. That's your answer for differentiating the original equation. But mathematicians don't really like to work with negative powers, so it's better to just tidy it up a little bit. X to the power minus a half, we can take the x to the power minus a half to the bottom of the fraction, and as long as we change the power from positive to negative. So let's see if we can do that. At the moment, you can consider it as being at the top of the fraction with the 5, but we can bring it to the bottom as long as we change from minus a half to just a half. And then the 5 and the fraction line can be above that as the top of the fraction. And that's your finished answer. Okay, I hope you enjoyed that revision session or found it useful. Feel free to watch the recorded session again and go over any parts that you weren't able to follow first time round. Please look out for further live stream mathematics A-level sessions. My name is Mr. Ali. Thank you for joining me.